When I visited my grandparents' home in India, we experienced a lot of power outages. And these power outages inconvenienced us in our phone and laptop usage when we needed these devices the most. On the other hand, we had abundant access to hot water because of these overhead water tanks that were directly heated by the sun. Now, this is possible because of the warm and tropical climate in India. So as I was observing this current problem of power outages, and I was thinking about this common resource of hot water, I started to research how we could harvest this thermal energy from the hot water in order to produce usable electricity. And this is when I learned about thermoelectric generators. Thermoelectric generators, also called TEGs, are these small square devices where if you put a heat source on one surface of the TEG and a cold source on the other surface of the TEG, then the temperature difference will allow for electricity to be produced. Now, to understand this better, I want you to think about a battery. A battery has a positive side and a negative side. Now, replace the battery with a TEG, and replace the positive side with a hot heat source that you put on one surface of the TEG, and replace the negative side with a cold source that you put on the other surface of the TEG. And you'll see that this temperature difference will allow for electricity to be produced. Now, as I was learning about thermoelectric generators, I was amazed by the real-world applications of these devices, such as the radioisotope thermoelectric generator, also called the RTEG. Now, the RTEG was developed and researched in order to power the Voyager space missions. These RTEGs were able to produce 400 to 500 watts of power to be able to power these spacecrafts. Now that we've gotten through the technical portions of the TEG, let's get on to the fun stuff, the experiments. Now, in this picture, you will see two water containers, one filled with hot water and one filled with cold water. You will also notice that there are aluminum foil sacks which are placed in the water containers, and the TEGs are actually sandwiched between the aluminum foil stacks. I completed multiple experiments with this type of setup to analyze how the temperature difference between the hot water and cold water was affecting how much voltage and current I was able to produce. Now, after doing some analysis, I realized that as the temperature difference between the hot water and cold water increased, the amount of voltage and current I was producing also increased. After completing this experiment, I was still interested in looking into various ways of increasing the amount of power that I was producing. And this is when I learned about series and parallel connections. If you take multiple TEGs and connect them in a series connection, then the amount of voltage that you're producing will increase. And if you take multiple TEGs and connect them in a parallel connection, then the amount of current you're producing will increase. Now, for example, if you take two TEGs and connect them in a series or parallel network, then you'll be able to produce 2 times as much voltage and current compared to just one TEG. The North Carolina State University was the first source that I hit upon to learn about the real-world applications of thermoelectric generators. Now, this research team was trying to harvest body heat in order to produce enough electricity to power our wearable devices, such as your Apple Watch or your Fitbit. I understood that this research team was trying to harvest our body heat when we're producing it the most, such as when individuals exercise. And this reminded me of all those sweaty summer rowing practices that I always participated in. And I was excited to try this experiment at home. So I took a heat sink as my cold source. And a heat sink, you typically find them in computers. They're there to cool down the electrical parts in a computer. I then took my hand, or the body heat I was producing, as the heat source, and sandwiched the TEG between my hand and the heat sink. As I was waiting for the multimeter to measure how much voltage I was producing, I was daydreaming about how body heat would revolutionize our world and could eventually allow us to power an entire village's light bulbs, only to realize that my body heat was only able to power one small green LED light bulb. So as I realized that body heat wasn't the best method for producing electricity, I went back to hot water and cold water. But this time, I wanted to power a larger device. So I found a toy train in my home, which has 4 LED light bulbs and plays Christmas carols. So I conducted an experiment with hot water and cold water and connected my TEGs to the setup, and then connected this train to the setup. I was able to power this train for about 40 minutes. This was a huge step in my process with my end goal because this meant that I was able to power a train which originally requires 3 AAA batteries with common resources such as hot water and cold water. After completing this experiment, I was still interested in investigating other heat sources that I could tap into for people who didn't have direct access to electricity would have access to. And this is when I thought about fire. Now, whenever our power goes out in our homes, we often light candles or light fires in our fireplaces in order to, for heat and for light. So I took fire from my fireplace as a heat source and snow from actually outside my home as a cold source and connected a very similar system and connected the train once more. Now, if you look up at the screen, you'll be able to see the results of the experiment. Is anyone in the holiday spirit yet? I have to tell you, I've never listened to so many Christmas carols after the holiday was over as I did that day. This was an amazing experiment for me because I was able to power this train for 3.5 hours just using snow and fire. I was so ecstatic by the results of this experiment that I wanted to take a step further and see if I could power a phone, which we use on a daily basis. Now, a phone requires about 4 to 5 volts, which is a much larger required voltage than what I've done in the past. So I completed another experiment, but this time I connected the phone as opposed to the train. I realized that my TEGs were not able to produce enough electricity to power this phone with the fire and snow as the heat source and the cold source. As the experiment continued, I started to notice limitations in my experimental setup, which restricted the TEGs from being able to power the required voltage and current to charge the phone. This is when I decided to take a step back and first make a better plan and gather some more materials to make the more compact and efficient system to be able to charge these larger devices. But now I know from my past experiments that maybe I could go back to India one day and use that hot water in the overhead water tanks in order to power my grandparents' devices in their homes. When I first started this project, I was not very knowledgeable about thermoelectric generators, but I was inspired to learn more from my motivation. I knew that this project could have great impacts, reaching students in New Guinea, Africa, allowing them to power their light bulbs in their schools. People could harvest thermal energy from fires, powering their heart with a pacemaker. When I first heard the words thermoelectric generator, it was just a month before the science fair. And when I first shared this concept with my parents, they were very skeptical of how far I would get, considering we had a time limit and we didn't know much about these devices. But I started with a small idea and tested this idea with an experiment. I then asked a new question based off of the results of this experiment and created a new experiment testing this question. I let the successes and failures of my experiments determine the path that I would take with this project. Taking this journey allowed me to realize that you don't need expensive equipment or a fancy laboratory in order to complete the research. All you need is motivation, a problem for potential for impact, and the drive to work hard. I see great potential for this project, and I'm very excited to see where it will lead me. Thank you.